Okay, we do have a test on, I was going to say Friday, but on Wednesday. Okay, this test is only differential equations. There are 10 problems on the test. 2 that are actual FRQs off of old tests, off of old exams. The other 8 are going to be problems very similar to what you see on the board or in the test review PDF that I sent to you, very similar to what you've been doing. There will be some relatively easy ones. There will be some not easy ones, but there are no multiple guess on this test. So that's what the test is going to be like on Wednesday. I do not think that it will be a 2-hour test like the last couple have been. I'll probably give you all that time if you choose to use it, but I don't anticipate it being that long. So I think it's very important, since we've been off for a week, to go back and work through. I think I put 22 problems here on the board. Work through these problems and be sure you understand how to do them. Quickly, how do we solve differential equations? Who can tell us?
Move x to the dx side and the y to the y.
All right. What does anybody remember what she just described, what we call that process? Separation of variables, okay? So that's really all you can do. You can separate the variables and then you can integrate. Now, I noted on your homework, a few of you at various times forgot the C. That's very important. Put the plus C there, okay? Unless you're given instructions on how to actually find the C, you should have a plus C in your answer. So we'll work through this one problem together. We're going to separate everything that has a y in it will be on my left side. Everything that has an x in it will be on the right side. We've got dy, we've got 4x squared plus 7 dx. And now we simply integrate both sides. So we put in our integral sign. If we integrate dy, what do we get? Y. And if we integrate 4x squared and integrate 7, we can integrate those two as two separate things. We should get 4 over 3x cubed plus 7x plus c. The plus c is a point, just like it was on your homework. So if you leave it off, you lose a point on the problem there. That's the basics of everything that we do there. We separate, we integrate, we use all of our integration rules that we've been using since January. Okay? So I'm going to give you time to work through the problems. If we need to come back and work one on the board, I'll be more than happy to do so. To my knowledge, everybody in this room has everything turned in. This is not going to be graded. This is just for your review purposes here. Let me think for a second. Oh, I have dropped the lowest daily grade already. I have dropped the lowest FRQ grade for you. So whatever you see in RenWeb right now is your average, with the exception of this one test, which can obviously have a significant impact one way or the other. So the time is yours. Slide 3. Who can also, you do it, okay? She wasn't saying you do it, she was saying you do it, okay? So you is what? I thought she meant you do it first. U is x minus 5. So then if u is x minus 5, du is dx, okay?
X is
X is u plus 5. So suddenly we can change this to dy equals u plus 5 times u to the 1/2 du. Now you can distribute and integrate and get to what you want to there. Because once we distribute, we get u to the 3/2 plus 5u to the 1/2 du. Now if we integrate, y equals x minus 5 to the 5/2, 2/5 of that, plus u to the 3/2, 10/3, whoops, not u, x minus 5 to the 3/2 plus c. I believe that would be the proper answer there. Does that make sense now, Colin?
Yes.
All right. Okay, slide 17. So how are we going to separate here? Looks like 2xy dy equals x squared plus y squared dx. It's a good question. I don't think so. Hmm. Any suggestions on what to do here? Yeah, but we need to get this y squared over here. I don't see how we're going to do that.
But x squared plus, no, minus 2xy plus y squared is the square root of, is the square of the x minus y.
Uh-huh. I agree with you. I don't know if it helps you out or not.
No.
Because then you get x minus y quantity squared. All right, if we just I don't see how to separate those. I'm not sure what to do on that one. So skip over that one for the time being. Skip over it for the time being. I'll see if I can figure it out by tomorrow. To do the slope field, you need to get your x, your y, and your slope, which is your y prime. And we've got 1, 1, and when we put 1, 1 in there, we get 1 out. And we got 1, negative 1, and we get 1 out. 2, 1, that's 2 over 1, which is 2. 2, negative 1, that's also 2. And we do that for all the points then we want to come over here and plot the slope on those points. So over 1, up 1, there's the point. The slope is 1, so it should look something like that. Over 1, down 1 would be right here, so the slope should look something like that. Over 2, up 1, the slope is 2, so it just needs to be higher. Over 2, down 1, the slope would be like that. And you do that for all 1, 2, 3, 4, 8 points there. That's going to be on the test. That's 1 or 2 points on an FRQ right there, guaranteed. Okay, 1 means that it should be pointing, a positive 1 means if I go up 1 and over 1, I'd get on the line again. So then you want it pointing in about that direction. Positive 2 means I have to go up 2 and over 1 to get back on the line. So I'm not going to measure it out exactly, but just be sure your 1s are pointing in the same direction, 2s, your 0s are flat. Remember, your 0s are horizontal. So just be sure you've done that. All right, an exponential growth model. So tell me what you've done so far.
Well, exponential growth model is y equals c multiplication.
Mm-hmm.
And so, we know that y equals 150 when t equals 3, and y equals 100 when t equals 5. And then it asks to identify the enriched population continuous with growth rate.
Okay. So can you use this information to figure out what your C and your K are?
Well, we tried it.
Well, let's see. If we do this, we get 150 equals CE to the 3K, right?
Yes.
So then from that, I could say that C is 150 over E to the 3K, right?
Yes.
All right. So now in the second one here, I can say 400 equals C. I'm going to put that in for C. E to the 5K.
Okay. See, yeah, because we saw K and it made it really crazy. Okay, wait, so.
I think you always want to solve for C first.
So C equals 150 over E to the 3K.
Right, and do you agree with me on how I did that? I just plugged in and chugged out. Now I'm just putting that in over here, so I'm going to have 400 equals 150 e to the 2k, because I can subtract 5k minus 3k is 2k. This 5k and this 3k. One's in the denominator, so 5k minus 3k. All right, so now if I divide by 150, the zeros go away and 5 will go 8 and 5 will go 3. So I get 8/3 equals e to the 2k. Ln of 8/3 equals 2k. So k is ln of 8/3 divided by 2. And if we go over there to figure out what C is now, we could get an ugly number for it too.
Okay, so just leave it how it is.
I would leave it, well, I'm going to put that number in there in just a moment. But identify the initial population and the continuous growth rate. The initial population, what is initial population? T equals 0. What is y? That's what it's asking for. And you're right, it's always going to be whatever C is. Because when I put T equals 0 in here, I get e to the 0, so just whatever C is. So if I put my K that I found into there, I can figure out what my C is, which is going to be my initial population. So it'll be 150 over e to the ln of 8/3 to the 1/2. Do y'all see how I got that 8/3 to the 1/2? because it's ln of 8/3 divided by 2. It's the same as ln of 8/3 times 1/2. So we can move the 1/2 up. Why is it important to do that? Or why would I even consider doing that?
Well, would it change your answer?
No, it shouldn't change your answer. But if I do this, suddenly I've got now 150 divided by 8/3 to the 1/2. What 3? Ah, okay. Yeah.
Oh, because you need to get rid of that.
You're right. We need to put that in there. So let's go back and just do it. Since we've got a calculating device, let's just put the 3 and this ugly number in there. ln 8 divided by 3 over 2. And you can do all of this. Where did the 3 come from? Because here in our C problem right here, C was 150 over e to the 3k. So you can go ahead and use that and figure out what your C is. And what does the continuous growth rate mean?
That's K.
That's right. Continuous growth rate is just your K. So we actually found our K and our C in a part there. And then C part. What is 15,000? T or Y? Y. So put 15,000 in for Y and solve for T. Any ideas? The rate of spread is jointly proportional to the number of infected and the number of uninfected. So if X are infected, how many are uninfected?
K Y or KX plus 4.
We could say Y. Okay. We've got people.
Why it's not 4,000 minus X?
Yes, Y in this case could also be written as 4,000 minus X. Where did she get the 4,000 from? An isolated town of 4,000. What does that mean?
It means there's a total of people of 4,000.
Is the isolated part important?
Yes, because it's not yearly.
That's right. We're not talking about Atlanta where there's 2 million, but there's folks in and out every day. We're talking about an isolated little town on top of the hill. Nobody comes, nobody goes. Okay? So, how do we write the rate of spread of an epidemic? What could we say there? Maybe dx over dy? No, we're talking about time, aren't we? A week later. Dx dt, the rate of spread, is jointly proportional to the number of infected people. How many people are infected? X. How many people are not infected? 4,000 minus X. Does that look like it would work?
I don't get it. Why is this equation?
All right, it's jointly proportional. That means both of those things affected. So the K is just the constant of proportionality we always have in there. Does it make sense that we would be multiplying these two things?
Yeah, but where did we get 4,000 minus X?
Okay, there's 4,000 people in the town. Okay, the town's isolated. Nobody's coming in, nobody's going out.
Oh, so if X are infected, then 4,000 minus.
That's right. You either got it or you don't. So if X is infected, 4,000 minus X is the uninfected people.
That makes
Okay? So I think that will work for us. I think that will work. What do y'all think? Try that and see. I'm going to look. Let's see if we can get to at least where they were at there, okay? So, let's see, we're going to say dx equals k dt, and I'm going to bring over here over x over 4,000 minus x. That's bringing the x's over there. All right, now how can I, isn't that right? Because I got to divide by those, so they're going to come over like that. So what did they do there? They just said, poof, something happened, right? Yeah, they just said, poof, something happens there. How does that poof happen? Anybody got an idea?
You know, I think only our God knows up in heaven. So, and you know, I was praying about it, and I think He really would enjoy to see His children happy. And His children would be happy if we just omitted it. There we go.
All right.
Praise Jesus.
I don't think we're going to go that far right now, okay?